Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by satsearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello everybody and welcome to today's episode of the Space Industry Podcast. I'm joined today by Stefan Frey, co-founder of satsearch member company Vyoma. Vyoma is a European company that's developing solutions to protect space assets. This is a really interesting and an increasingly important topic in the industry, and I'm quite excited to get into the detail of this with Stefan today. Specifically, we're going to discuss the current state of the Space Situational Awareness domain. But before we get into the questions, hi Stefan, thank you very much for being here today.
Hi, Howell. Thank you very much for having me.
Great, no problem. Okay, so as I mentioned, an increasingly important topic that a lot of people are focusing on. And I wondered if first you could just sort of ground us by giving a brief overview of the current space debris environment in the different orbits. If we just look at LEO, MEO, GEO, and where do you see most of the threat, actually the real threat, emerging for satellite operators potentially?
All right. So assuming that your listeners already know what LEO, MEO, GEO means, I'm just going to take it from there.
I hope so.
All right. So most of the objects that we currently see up there are actually in the low Earth orbit, so in the LEO region. And it's becoming really increasingly congested and making satellite operations around the altitudes of between 500 to 800 kilometers really increasingly dangerous as well. And that means the satellites there actually have to perform regular collision avoidance maneuvers just to make sure that their assets remain safe. If we go up a bit farther to MEO and GEO, so MEO is where the GNSS satellites are, and then GEO is the point in the orbit that doesn't move with respect to the Earth's surface. It's not so congested yet, even though, especially for GEO, we have to say that there are a lot of objects already up there. And it's, of course, because of it, the fact that it doesn't move with respect to the Earth is a very precious orbit to have. So, of course, we have to take special care there as well. However, I think as with respect to LEO, it seems to us, and I've been working at the European Space Agency, actually looking into how the different actors in space behave with respect to the space debris mitigation guidelines, is that in GEO, actually, they're behaving quite well because they know that they have to protect their own slots, right? While in LEO, it seems to me personally, it's more of a tragedy of the commons, basically, where you just say, okay, it's not my problem. I'm just going to throw it in there. With regard to MEO, maybe as a last point, I think the danger there is basically the GTO, so the crossing orbits, which are today not well observed, and we don't know very well where they are actually.
Okay, interesting. Yeah, it's obviously the incentives that different companies are actually under to look after their systems and look after their debris change dramatically with the size of the systems, the orbit. So that's a good overview. Thank you. And then in terms of tracking these assets, what sort of the different space-based and ground-based sensors or systems are used or of interest for space situational awareness? And what kind of resolutions are needed or can be provided in order to identify space debris?
Right. So in terms of space-based observational capabilities, there's really not that much today. So I'm just going to focus on the ground-based solutions that are out there right now. And I think the most prevalent in terms of technology are radar and optical, especially when it comes to cataloging objects. There are other technologies such as laser ranging. However, you need to already know where the object is to be able to actually point your laser in the right direction, right? Most of the data that everyone, especially everywhere, but also here in Europe, is getting access to is actually coming from US Spacecom. So it's an American with a connection to the US military, actually. So they have a very large ground-based radar, but also optical network. So they're observing objects in LEO, MEO, and GEO, and they're providing this kind of information in the form of TLEs, so two-line elements, but also special ephemeris, special perturbation ephemeris. So this is a very great source for everyone working in the industry to understand what's the situation up there. However, we have to mention here that they are tracking roughly 45,000 objects And that, based on or an existing 1 million objects that are up there right now. So we as humanity, basically, we see less than 5% of the dangerous objects that are actually threatening our satellites. And this is something that we would like to change at Vyoma. In terms of revolution, you were asking as well, it always depends for radar, especially it depends on the energy you put into the radars. Because as you might know, there is the radar equation. That means, the more energy you put in, the more signal you will get back. But the problem is that this signal gets weaker with distance, and it gets weaker very fast. And that's not only distance, but also the size of the objects that you're looking at. So right now, the US Spacecom catalog is more or less tracking objects that are 10 centimeters and larger. There are radars that are capable of going lower. I want to mention here Tyra in Germany. They can see centimeter level objects as well. However, they really have to put in a lot of energy. And right now, in the current geopolitical situation, spending that much energy is really not what you want to do. And at the same time, it also burns your instruments. So the wear and tear of putting through so much energy is actually making it very costly for operations.
Right, excellent. Are there any other sort of pros and cons for the different types of sensors and systems used?
Yes. So if you're comparing, of course, ground-based to space-based, I think one big pro for ground-based obviously is maintainability, right? So if something is broken, there is no issue, and you just fix it. On top of that, you have energy available on ground as well. You have generally a lot of heritage that has been around for many decades already. But if you look at the cons from radar, for example, from ground-based, is as I mentioned before, is the distance to the target, right? So the farther away it is, the less signal you will obtain. So this is something that, especially if it's passing exactly above you, that's easy to catch, right? But if it's somewhat far away, you're looking at it at a lower elevation angle, it will already get much harder to catch it. If you look at optical ground-based telescopes, they are very simple to set up. They're quite cheap, and they can really provide the data as well in no time, right? Because they're connected to the internet or connected to a computer, which is, of course, another con if you're looking at space-based, because there you really need to make sure that you have inter-satellite link, which is doable, but you have to make sure, and this is what we're doing, that they do a lot of onboard processing already, right? So you're not going to be able to download all the images in full resolution, but what we can do is we actually reduce those images down to just the small parts of interest for us. So really, actually, that's image coordinates of where the objects are that we see, plus some coordinates of stars as well. I also want to mention some pros of being space-based, especially for optical, of course, is to have a constant sun illumination angle, right? This is something that you don't have when you're on ground. You're also struggling with weather, atmosphere. So there's a lot of time, actually, your telescope is not going to be running. While in space, we can really achieve a near 100% duty cycle. So what does that mean? Actually observing all the time. And on top of that, we don't have light pollution, so we can achieve a very high sensitivity when we are in space.
Excellent. Okay, that makes sense. You touched briefly on the work that you guys are carrying out at Vyoma in the space situational awareness market today. You also mentioned earlier that there is a volume of data or sources of data available, and I believe there's plenty that can be accessed for free, albeit for a limited number of objects compared to what is actually up there. So within that environment, could you explain a little bit more about where Vyoma sits and what work you do and plan to do?
Yeah, absolutely. So indeed, one thing is, going from 45,000 objects to actually seeing and warning operators to 1 million objects. But this is not the only thing we're working on, basically, because what we want to achieve as well is help satellite operators actually avoiding unnecessary maneuvers. So how do we do that? We do that by observing objects more often than is currently being done. So shrinking the uncertainty about the location where they are. Because every time you observe them again, you can shrink the uncertainty of where they are. Plus, I also want to mention here that we have a very good understanding of the environment where satellites are flying. So we have near real-time calibrated atmospheric density models. What does that mean? We're actually taking observations from satellites that are already in orbit. and feed those into our models to get a better understanding of the environment they're flying in. And all of this really helps us predicting better where objects are going to be. So in terms of avoiding unnecessary maneuvers, that basically really means that we can tell satellite operators with our improved data and our improved predictions that they actually don't have to maneuver, while maybe with previous available information, they would have to perform this costly maneuver, right? And why are these maneuvers so costly? This is simply because you have to basically turn down your services that you usually provide during the time of doing the maneuver. And of course, you have to involve a lot of specialists also performing it. Anyway, though, the SSA part for us at Vyoma is really only the foundation, right, for our automation solutions. So our vision really is to shrink operation centers to the tip of your finger, basically, make sure that you can operate your satellite from a tablet.
I see. And to go back to the maneuver, monitoring and when you need to give notifications and things, how much of a heads up can you potentially give satellite operators about a potential threat to an asset? And how accurate do you believe your assessments can be?
Right. So we can give a heads up or an early warning already weeks before an incident. Yeah. But indeed, this is not necessarily useful because, of course, the uncertainties grow over time, right? I think what is much more important actually is reducing the time of still obtaining information right before taking decision to do the maneuver, right? And this is where our solution comes in as well, because we're screening all the objects a couple of times per day, basically. So we can, first of all, predict when we can make an update. So giving operators a heads up when the next information data point will come in. Plus, we don't have weather-related issues, right? So this is a very high reliability on providing this data. So the idea is to provide a data point very shortly before the actual time of predicted collision, right? And then give operators the possibility to wait as long as possible to take the decision to do the maneuver. Because we believe that in most cases, there is actually no maneuver required, right? Because it's simply, once you have better data, you actually know that it's going to miss your satellite. Just to give you one more data point here, today, satellite operators are moving out of the way if the collision risk is higher than 1 in 10,000, right? And what that really means in a very simplified way is that 9,999 out of these 10,000 maneuvers are actually not required.
Right. That's an enormous amount. I'm very surprised at that. But just the nature of the lack of information or accuracy that we have in the domain. So that's interesting. Now, I know that there's a number of teams working on different aspects of space situational awareness. I was at the IAC in Paris last week, and there were several teams, exhibiting there. So there's obviously a growing demand because of the amount of objects up there, but there's growth on the supply side as well, which is from a marketplace perspective, which is where we are at satsearch. This is great to see. But from your perspective at Vyoma, do you see a need for greater coordination within this community to mature SSA systems and make it a more kind of trusted area of the space industry?
Now, there is no doubt that bundling together observation data, fusing observation data from different places will make any product more accurate and also reliable. Of course, on top of that, we can also validate each other's solution, which I think is something that is currently lacking because everyone is just relying on one single source of truth. So yes, indeed. I mean, there is no doubt that we have to collaborate with each other. I don't know exactly in terms of coordination. That sounds a bit like it's something from top down, which I don't think is required, basically, because we strongly believe that all the solutions in the end will be somewhat distributed, making them much more reliable. Also, in terms of if one system stops working all of a sudden, basically. So we really do believe in a distributed system. On top of that, I think what's really cool about our industry in space in general is that we're all driven by a sense of urgency of solving this problem, right? So it's much less competitiveness. I think it's much more a collaboration that is intrinsic to everyone working in this domain.
Yeah, that makes sense. And I think the nature of what the satellite operator is trying to achieve by using your data, move a system so that there is an impact, is by nature kind of collaborative, because you're moving it out of the way of space debris or another existing satellite. You're trying not to create further debris that would damage other companies who may be your competitors' systems, So, by nature, it's a safety for all.
Yeah, help each other to help yourself, right?
Yeah, absolutely. And on that, are such satellite operators, spacecraft operators, able to use threat assessments to move their assets when they don't have propulsion systems on board who can maneuver, or they've run out of propellant, or the propulsion system isn't operated at the moment? And how long might they have to act? You mentioned the times you give them before a potential conjunction, but that would vary by orbit as well, I'm guessing.
That's correct. Yeah. So what they can perform are differential drag maneuvers. What does that really mean? So they can rotate their satellite to achieve a different area to mass ratio. Because there is still a bit of atmospheric drag left where most satellites are flying right now. So if you change the area that is actually being perpendicular to your velocity vector, then you can really change the resistance, and you can actually slightly change the orbit towards your normal operations, your normal attitude that you would have. Of course, it depends a lot on the shape factor of the satellite. So, or the side's very long as compared to the front. And as you say correctly, on the altitude of the orbit, because the lower you fly, the more drag effects will be there on your orbit. But indeed, so significant changes can be achieved. I think what's important here again, it's not so much how early you have to do it, but how well can you predict where it's going to be, right? So if you can say we're fine with missing an object by 10 meters, then of course you can wait really, really long until before it happens. But if you say, okay, we want to make sure that we miss it by 200, 300 meters, then of course you will have to start quite early. It's actually a similar problem for satellites that have electric propulsion available only. They also have to make sure that they start thinking, hours, maybe even days before closest approach itself.
Right, that's very interesting. And are there any recommendations that you would like to give satellite builders from the awareness of getting ready for space situational awareness and being able to carry out the right maneuvers and understand the data that you're being provided and things? Is there any advice you'd like to give them in the early stages of a mission?
Right. I mean, do consider space debris and related additional requirements very, very early in the process. Of course, the later you start trying to adapt the design to these kind of risks, which are very real, the more expensive it will get for you, of course. Also, I think, so ESA is actually going towards an index that, tells your mission on what's the footprint that you have on the space environment, right? That's taking into account the risk of colliding, but also the risk of having an explosion on board, basically. So if your payload permits, really try to avoid the most congested regions, right? Just go somewhere where the risk of collision is much smaller. That can be just, going to maybe 1,000 kilometers instead of going to 600 kilometers altitude. So if your payload allows it, try to avoid the congested regions.
Okay, brilliant. So start from these assumptions. There are going to be potential for you to impact something. There could be debris affecting you. Start like it. Don't build a satellite assuming it's never going to happen.
Right. Unfortunately, yeah. So just to give you also one more update here. So since the dawn of the space age, there have been more than 500 explosion events happening in space. So this is something that it's really real, right? Collisions are much less frequent. There have been so far 4 confirmed collisions in space. Nevertheless, it's getting more and more risky.
Then I was also interested in how the data that is being collected and provided and the systems that are being developed can have an impact on the other aspects of a satellite mission and its administration. So interesting aspect of this. So towards the insurance for space assets. So do you see insurance industry maturing and offering schemes that spacecraft operators can adopt based on SSA assessments that can be provided? And is this industry ready for using that sort of data for transforming their operations in this way?
Right. So it's not going to surprise you that, of course, we're talking to the big reinsurers that also have space insurances. And indeed, so what we see really is them towards really taking this problem seriously. So today, space insurance generally covers any loss of satellite in operations in space, right? And that can be from space debris, that can be from a faulty battery, from a faulty payload, whatever. And this is, I think, because of 2 reasons. This is because space debris is still a small part of the overall failures that you can see in space. And secondly, often it's not clear what is the actual cause of a failure, right? Because sometimes you just lose communication and that's it. You don't know exactly what happened. But with a better pool of data that we will have in the near future, and with better modeling capabilities as well, this will change, because we can predict, or we can also tell you what was really the cause of this. So what we think, or what we see the space insurance is going towards, is a model where if you actively consider space debris and you actively perform avoidance maneuvers and you react to space debris, your insurance payments will actually be lower. So there is a real financial incentive as well to behave responsibly in space.
Yeah, well, that makes sense. Think about it from the point of view of traffic on the road. If you couldn't see out the windscreen to see the other traffic, then you should pay more for insurance, I think. So
yeah, I think that's a very accurate. That's actually a very accurate description even of space.
Great, that's fantastic. So a final couple of questions. I think just to get back into the technical aspects of it and the hardware and software, with this emerging environment on the administration side and the different combination of data systems, and you mentioned the use of ground-based components and hardware, what combination of sensors do you see in the future has the best potential to give a satellite operator, for example, a complete, or as complete as possible, of a picture of the environment in which they're working?
Indeed, it will be a combination of radar and telescopes as well, because they give you a different set of data. So radar generally gives you range and range rate, so how far away is the object and how fast is it moving with respect to you. And telescopes give you angular information of where the object is, right? On top of that, radars are generally very good in spotting objects that are of metallic nature. So they will give you more signal back, while they're not so good in seeing non-metallic objects. On the other hand, telescopes can see bright objects that can be, even paint flakes, right? Which would not be possible to be caught by radar, for example. So it will be definitely a combination of these two types. I think if you want to go to even more precise orbit determination, you will also want to have access to laser ranging information. So what we're actually working on now for our second generation of satellites is, because the first one is only going to carry a telescope, is also considering radar or LiDAR. So kind of technologies that are capable of measuring the range and the range rate. The only problem with these kind of technologies is that they're generally limited in range, right? While we can actually see from LEO to LEO, LEO to MEO, and LEO to GEO as well with optical, this will be much harder to achieve with any kind of technology that can do range and range rate in space, right? Because we don't have access to unlimited source of energy there.
Right, thank you. That's a good summary. And finally, then back to finish on Vyoma and your personal ambitions and excitement about the company as well. What role do you see Vyoma playing in the European space agency or global space industry moving forward? So where do you see yourselves? What are you most excited about in the company?
Right. I think we really see ourselves as a supporter and also an enabler of satellite operations, an enabler of, the whole space industry. And we really want to do this by just making operations safer, but also by making it much more affordable. Because right now, go to market for new brilliant ideas of having some payloads in space, it just can take years, right? And it will take so much effort for people that have no experience or no network of actually being able of pulling this off, right? And we really want to make this much simpler by providing this kind of operation center as a service, basically, right? Satellite operations as a service. So we really want to contribute to a growing space economy, but also, of course, while keeping this critical infrastructure safe. I think if we can do this, then we have accomplished our mission.
Right, fantastic. Thank you. Well, best of luck in accomplishing that. And that's a great place to sum up, I think. Thank you very much, Stefan. It was really great talking to you today. I think you shared some great insights on what space situational awareness actually is, why it's important, how objects are detected, how satellites and systems move out of the way and when they should, when they shouldn't, and what satellite operators need to think about from kind of day one of mission development in order to adjust for the environment in which they are going to be, hopefully operating, assume everything else goes well. And yeah, great to hear about the plans that Vyoma has as well. So on behalf of, all our listeners at Space Industry Podcast, just wanted to say thank you very much for being with us here today.
Thank you, Howell, and thank you for your work as well. I think this is super important to, spread the word and make sure that people understand the risks of satellite operations, because today, most people don't understand that there are services that every one of us uses daily are at risk of being lost, for good if we have a catastrophic event in space. So thanks a lot.
Oh, you're welcome. And yeah, this is to everybody listening. This is very much an area that benefits from everybody engaging with and being involved in. So please do look into this area and see what you can find out about what's important to your industry, your missions, your products and services. And as always, we will share some further information on Vyoma's work and products and services in the show notes, and you can also find details of everything on satsearch.com and on the company's website. And just wanted to say thank you very much to all the listeners out there for spending time with us today. We'll be back with you soon on the Space Industry Podcast. Thank you. Thank you for listening to this episode of The Space Industry by SatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.